Good morning, everyone. Today we are going to continue with chapter number 6, that is object oriented analysis. We are going to start the chapter number 6, object oriented analysis. These are the contents from the chapter number 6, that is iterative development, rational unified process, that is RUP, then inception, then understanding requirements, use case model from inception to elaboration and elaboration. So we are going to start with iterative development. So iterative development is a software development approach that breaks the process of developing a large application into smaller parts. So iterative development, it is the process of breaking down. It is a process of breaking down the system development into a series of iterations, or breaks that process of developing a large application into smaller parts. That smaller parts, or that each part is called as iteration, that represents the whole development process and contains planning, design, development, and testing steps. So unlike waterfall model, the iterative process adds features one by one, providing a working product at the end of each iteration and increases functionality from cycle to cycle. There are multiple iterations in iterative development, and each iteration contains that several steps of software design, that is planning, design, development, and testings, like others, like a waterfall model. So here you can see the iterative development and the iterations. Here you can see the example of iterations, like this is the first iteration, contains the several steps of software development life cycle. Then second iteration contains some steps that we are going to start from the previous step. Then the third iteration. Okay, these are the several iterations in iterative development model. Here, here you can see that first iteration one, here iteration one having some steps like requirement analysis, design, testing, implementation, and review. In second iteration, we are going to start with the step design. That means backtracking is possible in iterative development. We can start from any steps after the first iteration. Then at the third iteration, we are going to start with that design step, and that we are checking for that implementation area. You can see. Okay, these are the steps, the iteration in iterative development. Okay, so each iteration is an incremental improvement. Here you can see each iteration is an incremental improvement leading to an evolutionary approach. Okay, so this is all about iterations from iterative development. Then here you can see the iterative development incremental model. This model is from software development lifecycle here. Uh, it contains the SDLC steps: communication, planning, modeling, construction, and development, noted by like ABCD. Okay, these are the software development lifecycle steps. Okay, so here you can see the increment one, increment two, up to increment n. So here you can see delivery of first increment, delivery of second increment, and delivery of nth increment. The first increment contains all the steps we are going to perform. Then in second iteration, we are going to perform again all the steps. Likewise, up to nth increment, we can move further. So in iterative model, we can backtrack. Backtracking is possible, that if uh, we fail at that modeling stage, then we can go back to that planning state and again restart that step. Okay, so this is possible in incremental model. So here you can see that iterative development versus the waterfall model. See the waterfall process here. Waterfall process includes the steps requirement, design, code, integration, and test. And similarly, that iterative process contains the several iterations having all these steps. In first iteration consists of all the steps. Second also consists of that all these remaining steps. Okay, so here you can see that backtracking. See the cycle here. That backtracking is possible at iterative process, but in waterfall process, backtracking is not possible. First, we have to complete that first stage successfully, then we will move further with that next step. Otherwise, if we are stuck with the first step, we can't move to the next step. Okay. So here you can see in waterfall model, the software development is done in a linear sequence. Yeah, in a linear sequence in waterfall model, and no backtracking is there in waterfall model. That means each phase must finish completely before proceeding to the next phase. That means, as I said, each phase must finish its work, while if it is not finished its work, we can't move to the next step. But in contrast with that iterative development, it provides frequent backtracking of stages to uncover the difficulties early in development, which makes overall system development less costly and more qualitative. In iterative development, we can backtrack. Okay, backtracking is possible in iterative development. If we stuck with that any step, then we can move further, or we can backtrack and again restart the steps. Okay. Then the advantages of iterative development. So there are several advantages or benefits of iterative development. There may be a question in your exam like give the benefits of iterative development for 5 marks. So there are several iterative development. From that, risk mitigation. Risk mitigation means it finds and mitigates the risk. Risk like requirement risks, architecture risks, technology risk, or process risk, or any other type of risk is there, then it will find and mitigate that risk by exposing problems earlier in the development process. The problems, if that risk or that problems are in that development process, then it finds and mitigate that risks. Then accommodating changes means this approach allows accommodating changes like functional changes, tactical changes, or technology changes in that implementation strategy. Then third one is learning as you go. That means it allows the system development organization to grow, to learn, and to improve through the continuous process of improvements and that feedback loops. Feedback loops, we have seen that the cycle. Then better opportunity for reuse, then greater quality means each iteration includes integration and testing, which results in quality of software. It also allows software to improve by giving some time to the process itself. Then greater predictability and minimizes losses. It can predict that failures in early stages. Okay, so these are some advantages of iterative developments. Then iterative development process includes four major milestones. There are four phases in iterative development. These four phases are inception, elaboration, construction, and transition. These are the four phases of iterative development process. So that inception means it identifies project scope, requirements like functional requirements and non-functional requirements, and risks at high level, but in enough detail that work can be estimated. If we are aware with some enough details, then we can estimate that, or we can identify that scope and the requirements in that inception phase. The next phase is elaboration phase. Elaboration delivers a working architecture that mitigates the top risk and fulfills the non-functional requirements. That is, it is an agreement on design approach, which includes some baseline architecture describing most of the requirements in detail. It does not include detailed design. Elaboration phase does not include the detailed design of that architecture or software design. Then third one is construction phase. Construction phase applies approach in the form of code. It designs actual working product on which testing is also done. It designs the actual working product. That means it incrementally fills in the architecture with production ready code and produce from that analysis, design, implementation, and testing of the functional requirements. Then fourth phase is transition phase. It delivers the system into the production operating environment, and it also validates the solution and take stakeholders acceptance. These are the four phases of iterative development process. So here you can see the iterative life cycle graph. These are the four phases of iterative development: that's inception, elaboration, construction, and transition. Here you can see the disciplines like business modeling, requirements, analysis and design, then implementation and test, then deployment, configuration and change management, project management and environment. Here you can see the graph or the flow of that graph in that four phases. Like here initial phase, that business modeling and requirements are present in the inception phase. In that inception phase, we are going to identify the requirements and business model here. In elaboration phase, see the active disciplines in this uh, elaboration phase, then construction phase, and in transition phase. In transition phase, we are going to validate the solution like configuration and change management, project management, and see the environment here. And in construction phase, the major focus is on in construction phase the major focus is on implementation and test. Then in elaboration phase, the focus is on analysis and design. So this is all about iterative life cycle graph. These are the four phases, then the disciplines, and see the iterations. Iteration for all the phases. Then next one is rational unified process, that is RUP. That rational unified process, it stands for RUP, that is RUP means rational unified process. RUP is a software development process from rational, that is a division of IBM. Then it is a unified process is architecture centric. Unified process is architecture centric. Here that unified process is the popular and effective object oriented software development process. Then RUP is modified at rational software, and it is widely practiced and adopted by the industries. This is from the rational, and that is the division of IBM. Here there is one question in your exam like, does unified process architecture centric? So we have to justify that. So yeah, that unified process is architecture centric. Why? Because here that unified process focuses on early development and design of independent executable modules prior to committing for full scale development. Then components that are most likely to change, and the components that can be reused are first identified in and built in that RUP. Then that unified process develops a baseline architecture. It develops a baseline architecture describing most of the requirements in detail. Then the elaboration phase, that yields an executable architectural prototype. The purpose of that analysis and design workflow is to develop a robust architecture for the system based on the requirements that we have identified at the first step, to transform that requirements into a design, and to ensure that that implementation issues are reflected in that design. If we are going to identify any issues in implementation or in requirements that are reflected in the design after identification, okay. Then the features of RUP. Here the most important idea in RUP is iterative development. Iterative development. Iterative development is the sequentially expanding and refining a system through multiple iterations using feedback and adaptation. So here we have seen that RUP is divided into four phases of iterative development. So these are the features of RUP. Okay, so these are the four phases of iterative development, that is inception, elaboration, construction and transitions. So that each phase of that RUP has iteration producing an executable component of software. The duration of each iteration changes from phase to phase. The duration changes from phase to phase, from inception to elaboration, from elaboration to construction, and from construction to transitions. So these are the iterations that are producing an executable component of that software. So RUP address the problems of both the small projects and also the large projects. It also tracks the most possible risk by continuously tracking the system development. It makes proper planning and keeps the follow of mitigating the risk at early phase of software development. If is there any what we can say, is there any risk in the early phase of that software development, it will identify that and give the proper and make the proper planning of that risk. Yes, see the phases of iteration of that RUP phases. These are the phases, that is inception, elaboration, construction and transition. Four phases of RUP, and see the iterations here. Iterations at every phase, at inception phase, and see the continuity between that phases with that iteration. So here each phase of RUP has iterations. Each phase of RUP has iterations here, an executable that produce an executable component of that software. Here see the duration of each iteration changes from phase to phase. Duration changes from phase to phase. Okay. Then RUP is built on some six best practices. It is based on a set of six key principles of business driven development. So first one is adapt the process. Second one is balance stakeholder priorities. Third one is collaborate across teams. Then fourth one is demonstrate value iteratively. Fifth one is elevate the level of abstraction. And last one is focus continuously on quality. So these are the best practices for RUP, or we can say six key principles for business driven development. Okay. So this is enough for today's session. We will stop here. Thank you.